Hello everyone and welcome back again to yet another lecture of Merinos for Medicos. I know it's the first time I think I'm showing my face to you guys, and I really apologize from the bottom of my heart for a delay in our lectures. Anyway, let's dive into the topic without any further ado. So we'll be dealing today about the introduction of neuroanatomy. Now, why we have selected the introduction of this topic is because it's very important for us to know the the basics of neuroanatomy to grasp the further details. Like till 12th, you were just dealing about the components of the brain, but now we are going to dive real deeper into the very depth of the brain in medicine. The main importance of this is to understand the pathology of a disease, you need to know the which part or which portion or what is the anatomy of, or which is the structure over there that's getting affected. Okay, so so this will help you not only in your first year but also in your upcoming years of medicine and also in your medicine practice. So let's dive into our agenda today. So we'll be dealing with what's neuroanatomy, what's the classification of the nervous system, what's the neuroglial cells or the glial cells, the sagittal section of the brain and the coronal section, a bit about hydrocephalus and Dandy Walker syndrome. Okay, so what's neuroanatomy? Firstly, what's anatomy? Anatomy means it's the structural and the organization study of our body parts. So when it comes to neuroanatomy, which portion of the body does it deal with? It deals with the nervous system, obviously. So it is the study of the structure and the organization of the nervous system. Okay, so you might be well aware of some of the terms like encephalopathy and also. Why is this encephalopathy named? It actually is a disease of the brain. So encephalopathy means brain has another name known as encephalon. So it's relating, like, yeah, it is some disease associated with the brain, which I would be teaching you in further classes about what's encephalopathy and all. Okay, so what's the classification of the nervous system? Okay, so the nervous system, it's divided into two portions. First one is CNS and the PNS. CNS means central nervous system, which comprises of the brain and the spinal cord. Okay, now we have the PNS. PNS comprises of the cranial nerves and the spinal nerves. Okay, now the cranial nerves, it's been divided in further 12 nerves. Okay, 12 pairs of nerves, and the spinal nerves is divided into 31 pairs of nerves. Anyway, cranial nerves will be dealing in details in further videos, but spinal nerves, let me tell you, they are further divided into 5 groups. Okay, first one, starting from the head to below, it would be about cranial nerves. Okay, sorry, the cervical nerves. So the cervical nerves, they are actually 8 in number. Okay, then we follow then we move downwards, we get the thoracic spinal nerves. They are 12 pairs in number. Then we get the lumbar spinal nerves. They are 5 in number. The sacral spinal nerves, they are 5 in number. Then we have the coccygeal spinal nerves, that's 1 pair in number. Okay, so it forms a formula of C8, T12, L5, S5 and C1. So what is it? C8, T12, L5, S5 and C1. Okay, so let's go into the next topic, that is the neuroglial or glial cells. Okay, so these are supporting cells of the neurons. Okay, and they are basically astrocytes. You know, the name astrocytes came because these cells are star in shape. Okay, and the function of this is they form the blood brain barrier. How? They form a connection between the capillaries, and these cells, they are being derived from neuroectoderm. Okay, we'll be learning more about the embryology later on, but now we'll be focusing completely on this. Then we have the microglial cells. Okay, the microglial cells over here, they have been derived from the mesoderm, and the function of this is, it is phagocytic cells. And the phagocytic cells plays an important role in the immunity. Okay, now we have the ependymal cells. Ependymal cells has been derived from the neuroectoderm, and they are responsible for the formation of the cerebrospinal fluid, which is also known as the CSF. Okay, Okay, next we have the oligodendrocytes. Oligodendrocytes are also derived from the neuroectoderm, and they form the myelin sheath in the central nervous system only. Okay, now you'll be asking, like, if this forms this, if it forms the myelin sheath of only central nervous system, what about the peripheral nervous system, right? So peripheral nervous system, they have been formed by cells called Schwann cells. Okay, you can see over the image over here. Let me show you. So these are the Schwann cells which are responsible for the myelin sheath formation. You can see over here, as I said, star shaped, astrocytes and all. This is the microglial cells. And I forgot to put the ependymal and oligodendrocyte cells, but obviously you can check over in the Google about the images. You can see it well. Okay, so this Schwann cells, no, they are being derived from the neural crest cells. Okay, so if you see over here, among these four, astrocytes, ependymal cells, and the oligodendrocytes, these three have been formed or derived from the neural ectoderm, while microglial cells are the only cells of the neuroglial cells, the supporting cells, which has been derived from the mesoderm. Okay, now we have the sagittal section to learn about. So sagittal section is, if you cut me into half, how you will be forming, what all the components you can see if you cut me in half, from the brain side. So we have the three parts of the brain that's been visible: the forebrain, midbrain, and the hindbrain. Okay, so now this forebrain, just like brain has its another name known as encephalon, the forebrain, they consist, its other name is prosencephalon. Okay, the prosencephalon, it comprises of cerebrum. Cerebrum's other name is telencephalon, and thalamus, whose other name is diencephalon. So cerebrum, it consists of two, that is the cerebral hemisphere components, two of them, and thalamus, it comprises of all the thalami. Now midbrain, over here, midbrain is a very simple portion of the brain that comprises only of midbrain. Now we have the uh, hindbrain. So it comprises of the pons, the medulla oblongata, and the cerebellum in combination. So this pons and cerebellum, when they combine together, or when we, this both combination is known as metencephalon. Okay, before I forget, midbrain is also known as mesencephalon. Okay, now medulla oblongata alone is known as myelencephalon. Myelencephalon. Okay, myelencephalon. Okay, so let's go. Okay, so next we're going to deal with the coronal section or the plane. So I'm sorry for the image, but this is a very easy schematic diagram that will help you grasp it very easily. So I have, used my own notes image over here. So let's go from the forebrain to the hindbrain. Okay, yeah, so first we get the cerebrum. Okay, this portion over here is the cerebrum, followed by the thalamus over here, then we have the midbrain, then we have the pons, and then we have the medulla oblongata, which goes further into the spinal cord. Okay, I'm sorry for the spelling over here. It's actually magenda, magenda, magendi, sorry, magende, magendi, the spelling of that. Okay, so now we have the ventricles. Okay, we'll be learning about the ventricles in detail in the other videos, but I just wanted to give an overview of the ventricles too, or else you won't be able to understand it properly. Okay, so we have the lateral two ventricles over here in the cerebrum, present in the cerebrum, and then we have the third ventricle that's present in the thalamus, and we have another ventricle over here in the that's present in between the pons and the medulla oblongata. Okay, okay, now we'll be learning about the connections between it, like how it's connected to each other. So this lateral ventricle over here, it gets connected to the third ventricle via the foramen of the Monroe. Okay, Monroe, and then it connects from third ventricle to the fourth ventricle, and then you will be seeing over here, um, the foramen of Lashka, two sides, and then the foramen of the Majendi. Okay, the foramen of the Lashka, no, if you can identify this clearly, that you can see the Lashka L and the Majendi him. Okay, so Leshka means two lateral side and Majendi means the mid side. So if you see that there is this middle portion that I gave, this is the foramen of the Majendi, and this two sides over here, no, this forms the these are the foramen of the Leshka. Okay, now this um, what we can say, yeah, the third ventricle and the fourth ventricle, no, they are connected by the aqueduct of Stylus, also known as the cerebral aqueduct. Okay, okay, so that was it. Now we need to know that there's this thing called choroid plexus, which is nothing but network of capillaries. Okay, you don't have to pressurize over like what's choroid plexus and all that thing like that. Okay, so how is the CSF formation occurring over here? CSF means the cerebrospinal fluid. Lateral ventricles, they are the most important ventricle that releases the CSF, because the presence of choroid plexus in the lateral ventricles. Okay? The lateral ventricles, they consist of the choroid plexus, which is responsible for the CSF. So how does this course come? Like based on the connection over here. So the CSF that forms over here, it crosses the foramen of Monroe into the third ventricle, and from there it further crosses the aqueduct of Stylus and goes into the fourth ventricle. After which it divides into two sides. How? Either what happens is some of this, it passes into the central line into the spinal cord. Okay, it goes down into the spinal cord by the central line, now the foramen of the Majendi. Okay, it goes via that, and or else it can go from the foramen of Lashka, that is the two sides. You see this via these two sides, so it comes out into the brain. Okay, so this is just a portion of it, right? This is coronal section, so there are more parts of the brain, you remember. There are layers of the brain, so it goes into the subarachnoid space. Okay, and from the subarachnoid space it gets drained off into the arachnoid villi into the dural venous sinuses. Okay, so majority of this drainage, no, it's done by the it is occurring at the superior sagittal sinus. We'll be learning about the sinuses further in further videos. Okay, now we'll be learning about the hydrocephalus. So hydro means something fluid. Okay, it's fluid. Cephalus means it's a collection. Okay, so it's the accumulation or the collection of CSF which leads in the enlargement of the ventricle. So so the most common congenital most common congenital hydrocephalus that you see is the aqueductal stenosis. So what happens in this aqueductal stenosis is there is this narrowing of the aqueduct of Stylus. Now remember I said in the previous slide that the third ventricle and the fourth ventricle, how is it connected? It is connected via the aqueduct of Stylus. So there is a narrowing of the aqueduct Stylus. Okay, now when there is a narrowing of the aqueduct Stylus, you will be having what? When there is a narrowing, if you imagine there is water pipe. Okay, so there is this water pipe and I compress over a portion. So what happens? Is the water able to pass from that pipe downwards? No, right? Similarly, what happens is when there is a narrowing of this aqueduct of Stylus, there is the accumulation of the CSF. Where is this accumulation now? Because it's not able to go from the third ventricle, so it would be going into the fourth ventricle. Like it can't go to the fourth ventricle. So where is the accumulation going on? In the third ventricle. So there is a dilation. There is this dilatation of the third ventricle going on over there, and that leads in the formation of this aqueductal stenosis. And mostly where it is seen, it is a congenital one. Okay, so you can see over here in the image, you will be seeing that there is an accumulation of CSF in the ventricle. Next, we'll be going to the Dandy-Walker syndrome. So I said the previous one, it was the narrowing of the aqueduct Stylus. Here it is the atresia of the foramen of Lashka and the foramen of the Majendi. Okay, so if you see that there would be a normal thing over here. So by this, when I say the foramen of Lashka and the foramen of Majendi, so where do you think the accumulation of this CSF is occurring? Obviously in the fourth ventricle. So what happens over here? Because of the atresia, there is this narrowing occurring over there. Okay, so because of the narrowing, it's not passing. So the what I said, the fluid, it has to go either it has to go into the spinal cord as well as to the subarachnoid space of the brain. But this isn't happening. Why? Because there is a narrowing in this, or the atresia in the foramen of the Lashka and the foramen of the Majendi. So what is happening is the fluid gets accumulated in the fourth ventricle itself. So it forms a syndrome known as the Dandy-Walker syndrome. So that was the video for today. I hope you like this video, and if you like this video, don't forget to like, share, and subscribe to our channel. We'll be coming with more videos. Still then, stay tuned and happy learning. This is Sasha. We are just signing off for today. Bye.